This is all about electrolytes and solubility, more the solubility rules. So when I put, this is a weak electrolyte, as I can see there's no ions. Ions are the ones that have the charge. These are all what are known as covalent molecules, which would be like sugar. This would be a weak electrolyte. There's a little bit of a light bulb on. And it has a few ions, so just a little bit to carry a charge. These would be your weak acids and bases, which we'll talk more about next unit. Our strong electrolytes come in many forms. The main thing is there's a lot of ions that completely dissociate. If you look, this would be the compound together. Everything's broken apart. These are our soluble ionic, strong acids, strong bases. Again, we'll talk about these more next unit. We're going to focus on the soluble ionic compounds. So for example, what happens when salt, a strong electrolyte, is dissociated in water? So dissociate is different than dissolve. This means it breaks up into ions. So if we remember, water's polar. That means oxygen has a slight negative. That symbol just means slight, and hydrogen has a slight positive charge. So this would be our salt molecule, and it's going to be pulled apart by the water molecule. And if I look further down, hydrogen has that slight positive charge, which is attracted to chlorine's negative charge. And oxygen has that slight negative charge because it's highly electronegative. That's attracted to sodium's positive. So when I put salt in water, it's going to break up into Na plus because sodium loses 1 electron and Cl minus because chlorine gains 1 electron. So now what happens when ions react in water? So ion compounds that dissolve in water are soluble salts. They do not dissolve are known as insoluble. So I have an example. As you can see, there's all this solid. They're not in color, but you can imagine it. These are all insoluble salts that are formed after a reaction. So you look at the end. So we look at S, go down to S. It's all the way at the bottom. I see if cadmium, Cd, is one of its exceptions. It's not. Go over. This is insoluble. We have iron sulfide. So again, go to S. Look across. Fe is not one of its exceptions. Insoluble. Lead iodide. So we look at the end. We look at I. Go across. I see lead's right here, so that means I stay right here. Go up. Insoluble. Go across. Sodium hydroxide, so we're going to look at the polyatomic, the OH group. Go down to OH. Boop, boop. Sodium. Oh, sorry, that's nickel. My bad. So nickel is not one of my exceptions. Stay over here. This makes this insoluble. So you would see this. So all these are products. All these are known as precipitate. They're the products that form in a chemical reaction. They're what precipitate out. So for example, so I would ask you which one would precipitate out of reaction. So one of these would form the solid. That's the driving force of this reaction because both these are aqueous. So we let chlorine, chlorine's right here, go across, Pb's right here, so that means this is insoluble, so this would have been a solid in solution. Sodium nitrate, anything that's a nitrate is always going to be soluble. If you want, look up, sodium's not one of the exceptions.